Let's talk about the sums and difference formulas for cosine, sine, and also tangent. So, sums and difference formulas for the cosine and sine. Basically what you want to notice is the function name, cosine, and then if it has a plus or a minus. The function name, for example, sine, and whether it has a plus or a minus. Again, the function name and whether it has a plus or a minus. So, what we have then is we have basically the equations that go with them. Cosine alpha, cosine beta, and alpha and beta are the two angles for which you're working with. And your angles will be given to you so that we can figure out which one's alpha and which one's beta. But these again are the general rules that we're going to be sticking with. Let's look at an example here. Cosine of 100 times cosine 55 plus sine of 100 plus sine of 55. I've got two angles. One is 100 and the other is 55. So what do I have? I have cosine alpha times cosine beta plus sine alpha sine beta. Let alpha be 100 and let beta be 55. These are just the two angles that I have. So what I want to do is I want to go back and I want to look at my equations that I have. I need cosine times cosine plus sine times sine. Cosine times cosine, nope, I need a plus. Cosine times cosine, oh, there it is, plus sine times sine. That would be a cosine of alpha minus beta. Cosine of alpha minus beta is cosine alpha, cosine beta, plus sine alpha, sine beta. So if I'm going to let alpha be 100 and beta be 55, that means I have cosine of 100 minus 55. Alright, well, what's 100 minus 55? Well, that's 45. So that means I have cosine of 45 degrees. Oh, well, I have a unit circle that's going to tell me this. Cosine, remember, cosine is x. So at 45 degrees, what is the x? Square root of 2 over 2. And that's how we do these. We find the equation that we want, plug it in, and evaluate. This one, it says verify that cosine of pi plus theta is equal to negative cosine theta. Alright, I've got two angles here. Let's let one be alpha and one be beta. That means I'm going to let alpha be pi and I'm going to let beta be theta. Well, if I have cosine with a plus, let's go to our equations. Cosine with a plus. Cosine with a plus is cosine alpha cosine beta minus sine alpha sine beta. So I have cosine with a plus is equal to cosine alpha cosine beta minus sine alpha sine beta. Well, I know what alpha and beta are because I have them labeled here from the problem that I was given. So that means I have cosine of pi, cosine of theta, minus sine of pi, sine of theta. Cosine of pi means what's the x at pi? Okay, here's pi. The x is negative 1. So that means I have a negative 1 cosine theta minus sine of pi means what's the y at pi? Well, here's pi. The y is 0. So that means I have 0 times sine theta. Well, 0 times anything goes away. So that I have negative 1 cosine theta or just negative cosine theta, which is exactly what we were supposed to get. Okay, let's look at a couple more. 75. Now this one is telling you find sine of 75 degrees using the fact that 75 is 45 plus 30. That means I have sine of 75 is sine of 45 plus 30. Okay. Well, that means I have sine with a plus. Sine with a plus, go back to your equations. Sine with a plus, sine alpha cosine beta plus cosine alpha sine beta. So I have sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Okay, so that means that I'm going to have 45 be alpha and I'm going to have 30 be beta. Alright, so that means I have sine of 45 cosine of 30 plus cosine of 45 times sine of 30. Again, sine is the y coordinate and cosine is the x coordinate. So you've got your unit circle. So first of all, I want sine of 45 degrees. At 45 degrees, the y is square root of 2 over 2. I want to multiply that by the cosine of 30. Cosine is the x, so at 30 it's the square root of 3 over 2. Bring your plus symbol down. Next I want to go find cosine of 45 degrees. That's the x at 45 degrees, square root of 2 over 2. Next I want the sine of 30, which means I want the y coordinate at 30 degrees, 1/2. Fractions multiply top times top and bottom times bottom. So the square root of 2 times the square root of 3 is the square root of 6. And on the bottom we have got 2 times 2 or 4. For the next one we have square root of 2 over 4. They have a common denominator, so I'm just going to make them into one large fraction. These roots cannot be combined. Very good. Let's look at another one. Instead of having plus this time, let's look at this. This is saying sine of 15 degrees, but let 15 degrees be 45 minus 30. Oh, well, okay. That means I have sine of 15 is sine of 45 minus 30. Oh, all right. That means I have sine with a minus. Let alpha be 45. Let beta be 30. So I have sine with a minus. Sine with a minus. Sine alpha cosine beta minus cosine alpha sine beta. Sine alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. Well, I know alpha and beta, so I can now just plug in. So I have sine 45 cosine 30 minus cosine 45 sine 30. Well, these are nice because I just looked these up. Sine of 45 we found was the square root of 2 over 2. Cosine of 30 we found that to be the square root of 3 over 2. Bring your subtraction symbol down. Cosine of 45 we found that to be the square root of 2 over 2. And sine of 30 we found that to be 1/2. Again, fractions multiply top times top, so I get the square root of 3 over 4 minus the square root of 2 over 4. They do have a common denominator, so go ahead and make it into one large fraction. Very good. Let's look at some more. This time what we want to do is a little bit tricky. Because it says suppose, oh, I'm sorry, let me scroll out. Here we go. It says suppose that cosine theta is negative 3/5 for a quadrant 2 angle theta. And suppose that cosine theta is 12/13 for a quadrant 1 angle beta. Now, we know, for example, that cosine, let's see, I tell you what, I'm going to need some room, so let me get a piece of paper here. Alright, let's get a piece of paper so we'll come back to working with the A, B, C, D, these. We have to find a couple of things before we do that though, okay? First of all, I was told that cosine theta is negative 3/5. Now, if you go to your unit circle, you will not find an x value of negative 3/5. Why? Because this is not on the unit circle, okay? That means that it's on a larger circle, which means I have to understand that cosine of any circle is y over r. R is always positive. That means that r is equal to 5. And that means that y is negative 3. Well, if you have r and you have y, you know we got to go find x. Oh, I'm sorry. Bugger. Okay, cosine's x over r. There we go. Let me fix this up. Oh, goodness. One of those mornings. Okay, there we go. So it's x over r. X is the square root of, x is negative 3. That means I have to go figure out what y is. Now, the equation I'm going to use to figure out y, r squared is x squared plus y squared. Well, I know r is 5, so that's 5 squared. I know x, that's negative 3 squared plus y squared. Please be careful. 5 squared is 25, but please note that I'm taking the negative and squaring it and 3 and squaring it, so please be careful, that is a positive 9. Go ahead and solve for y squared by moving that 9 over. I do want the square root, so when I take the square root, I have to put a plus and minus in front of it, because now we have to go decide, well, which one is it? Is it plus or is it minus? Which one is it? Is it plus or is it minus? Now, we were told that cosine theta, right here, we were told that cosine theta was this, and theta was a quadrant 2 angle. Alright. Quadrant 2 points are what? Negative x's and positive y's. Does that hold up? Yeah, I've got a negative x here. The positive y means instead of plus minus, I'm going to pick the plus because I'm talking about y. So that means I have r is 5 and x is negative 3 and y is positive 4. Okay. So now, and these are the measurements for the theta angle. Let's go figure out the measurements for the beta angle. Alright. So cosine beta is 12/13. Again, if you go to your unit circle and try to find an x value of 12/13, you will not find it. The reason is because it is not on the unit circle. Well, if it's not on the unit circle, I know that cosine is x over r. R is always positive. Always positive. Oh, okay. That means that r is going to be 13 and x is going to be 12. Well, if I know r and I know x, I got to go figure out y. So again, we're going to use our equation. R squared equals x squared plus y squared. So I have 13 squared equals 12 squared plus y squared. So I have 169 equals 144 plus y squared. Move the 144 over by subtracting. Y squared is 25. But I want to take the square root in order to get just y by itself. But when you take the square root, you need to put a plus and minus in front of it. Again, square roots and squares, they cancel, so I'm simply just left with y. Now here's the problem though. Which one do I use? Positive 5 or negative 5? Well, let's go read the instructions again for the beta. From our original problem, it said that cosine beta was 12/13 and beta was a quadrant 1 angle. Well, what do we know about quadrant 1? We know that quadrant 1 is a positive x and a positive y. Does this hold up? Yeah, I have a positive x, which means that down here I'm going to pick y to be positive 5 because I'm talking about quadrant 1. Okay, that means that r is 13, x is 12, and y is positive 5 for my beta angle. Now we can go and do the problems from earlier. So here we are. First thing I want to know is I want to know sine of theta. Sine of theta is going to be y over r for theta. For your theta measurements, here were our theta measurements. For angle theta, we found y to be positive 4. So positive 4. We found r to be 5. So there we go. Sine of theta is 4/5. Let's go figure out sine of beta. Sine of beta, it's y over r, but this time you have to use your beta measurements. For the beta angle, my y was 5. My r was 13. So that means that my sine of beta is going to be 5/13. Let's figure out sine of theta plus beta. Sine of theta plus beta. Sine with a plus. Sine with a plus. Here it is. It's sine alpha cosine beta, cosine alpha sine beta. Okay. So let's use this. So sine with a plus. Sine of alpha plus beta is equal to sine alpha, cosine beta, cosine alpha, sine beta. For this problem, my alpha is theta and my beta is beta. So the question was, what is sine theta plus beta? Well, that's going to be sine theta cosine beta plus cosine theta sine beta. Sine theta we just found. Sine theta we found right here. We found to be 4/5. Cosine beta we were told. Cosine theta we were told. Sine beta we came up with. And then we just multiply our fractions. Top times top, bottom times bottom. So 4 times 12, 5 times 13. Bring your plus symbol down. Negative 3 times 5. 5 times 13. And then we're just going to finish the problem out. This plus and minus together, we understand that that's going to become subtraction. So 48 minus 15 will give us 33/65. And that is sine of theta plus beta. The second part of the problem, I'm sorry, actually the fourth part, here we go. Cosine theta plus beta. So this time I want to find, so this was part C, okay? Part D, I want to find cosine theta plus beta. For my equation, cosine with a plus, here it is. Cosine alpha cosine beta minus sine alpha, sine beta. So I've got, let's see, cosine with a plus. Again, I'm going to let alpha be theta and beta be beta. So cosine with a plus. I've got cosine theta cosine beta minus sine theta sine beta. Cosine theta we were told. Cosine theta we were told. Cosine beta we were told. Bring your subtraction symbol down. Sine theta we found. Sine beta we found. And now we just multiply. And now we just multiply our fractions. Multiply your fractions and subtract. So we've got 3 times 12 over 5 times 13 minus 4 times 5 over 5 times 13. Combine, we'll get negative 56 over 65. That means that cosine theta plus beta is negative 56 65ths. Very good. That one was a little bit more difficult. Very good.